Hi, I'm Liam Kelly, Director of Product Marketing for Topos Labs, and I'd like to thank you for having us at the AI WorldGov Solutions Theater to present our no-code natural language processing platform. At Topos Labs, we've created an NLP platform, Gracie, that enables non-technical users to build sophisticated machine learning models quickly without a single line of code. If you look at this view here, you can see that on the left we have Gracie. Using machine learning and AI, Gracie is capable of understanding human language quickly and at scale. If a human can interpret it, Gracie can too. On the right-hand side, we have you, your domain experts, your interns, whoever it is, the only skill they need is to be able to use a web browser. When we pair these two together, we get what we call augmented machine learning. Having a human in the loop drastically increases accuracy and cuts costs for building and tuning models. What I'm going to do is show you 3 different demonstrations for how non-technical users are using Gracie today to build unstructured text classifiers using nothing but a user interface. To start things off, we'll build a simple taxonomy, but when paired with Gracie, we'll find that we can add multiple layers of additional intelligence. So what I'm going to do is paste in a news article on a data breach that happened at Stack Overflow. Gracie's processing this text and telling us everything that's found. If we take a look at the results, we can see we have a main topic of software development and a main dictionary or category of technology. If we scroll down, we can see the lexemes, or words and phrases, their relevance, and the topic that they belong to that were found in the document. Most of these are about software development, with some with analytics, and internet and web in second and third. What I'd like to do though is teach Gracie what cybersecurity is and add that to our technology category. To do that, we can navigate to our dictionaries, which contain our general knowledge classification. You can see we identify things from education to sports. From here, we can go into our technology dictionary and add a new topic of cybersecurity. Within this new topic, we need to start adding lexemes, or words and phrases with definitions. If I click Add Lexeme, you can see on the side we have a lexeme panel pop out. This is where we can give aliases to this lexeme, or different ways of identifying this thing. You can have as many words or phrases as you would like, and a definition to associate with that lexeme. Here we can do a quick lookup to go to Wikipedia, where we can grab some content to give to Gracie. We can paste it in the brief text area and click Validate. What happens here is Gracie processes this definition and grades it for us. This bar measures how many words are available. Too few, and there's not enough context. Too many, and you're polluting the document. The next bar measures the quality. Ideally, the definition that you give to a word should belong to the dictionary and the topic that the word belongs to as well. This is Gracie grading this definition, telling us whether or not our definition matches the context it's been put in. Here we can see that this definition has been classified as being about technology as a main category, which is correct. However, the main topic is computers. While this isn't incorrect, we want Gracie to know that this is about cybersecurity. To accomplish this, we can add more lexemes to our topic of cybersecurity. We can import a CSV composed of 3 columns. First column of main name, second column of aliases, and the third column with a definition for each lexeme. We can click on any of these lexemes to see what the definitions and aliases are that we added. In this case, we're looking at adware and its definition. Next, we need to build a model. This will update our higher order model, technology, with the understanding of what cybersecurity is. After we do this, we can reanalyze this document and we can see what Gracie has found. So as we can see, we're now picking up the main topic of cybersecurity within this document. We can take a look at the stats to see where our software development topic falls. It's still high up within technology, but it's not the main topic anymore. If we look at the lexemes highlighted in green, we can see that there are 3 versions of the word attack: cyber attack, terror attack, and passing game. Cyber attack is much higher than terror attack and passing game at 82%, where terror attack is at 48% and passing game is at 41%. This is why we gave these words definitions, is to help disambiguate which version of which word we're looking for in text. This helps Gracie better understand context, even within sentences within documents. If we click on terror attack, we can see the Lexeme card pop out on the side. We have the Lexeme terror attack, found at a 48% relevance. It belongs to war and weaponry and terrorism, has aliases of different ways to identify that word and a definition associated with it. This definition is being graded as belonging to terrorism, so we know it's a good definition for the context it belongs in. If we look at cyber attack, though, we can see that the relevance is at 83%. And if we scroll down to the quality of this definition, we can see that it's gone way up to 88% cybersecurity. This means Gracie has learned what the definition of cybersecurity is and is grading our definition for cyber attack as belonging to that new topic that we just created. The advantage to building these types of models is that you don't need any natural language processing or machine learning AI experts to lead this process. Our models are built by either liberal arts majors or domain experts who know exactly what they're looking for. And the fact that building these models takes seconds rather than weeks means that you can see results instantly and know what needs to be fixed and what needs to be changed. So to recap, in 5 minutes we built a taxonomy that uses terms with built-in disambiguation to increase accuracy without using traditional training texts that can support any number of aliases. For this example, I'm going to build a research paper classifier within Gracie. The end result will be that I'll be able to give Gracie any kind of text and have Gracie tell me if it looks like a research paper. I have one research paper here to see what she already knows. If we paste it in our editor and process, we can see the results. What we get back is everything of value Gracie has found in this document. We can see here that Gracie has classified this text as being about building and construction as a main category, with a main topic or subcategory of manufacturing. This classification is from our out-of-the-box ontology, which contains over 30 dictionary models, 200 topic models, 7,000 lexemes, and 150 document types. This is great so far. I haven't built any custom models, and we already have some good information. If I open up the stats screen, I can get a deeper look at what Gracie thinks. Here we can see the top 3 dictionaries and the top 3 topics of each's classification. If I navigate to the Skill Sets tab, we can see that there are no results. So far, it's plain to see that we know what this document is about, but we don't know what this document is. To build the research paper model, I can go to Skill Sets and create a new skill set called Research Paper. Within this skill set, I can make a new skill called General Research Paper. I'm calling it General because I don't want to make a model too focused on one particular field of study. I want it to be able to understand research papers from any field of study. We're now inside an empty skill. Here's where we can build and edit our model. To start, we can upload training text. These will be research papers that we use to teach Gracie. To start, I will only add 26 examples of research papers to see if we're on the right track. Now to build a model. I can click the Build Model button at the top of the screen. As you can see, the process took roughly 1 second. This is made possible from our global language ontology, a patented method we use to build models with very few training texts, no negative examples, in seconds. We can see Gracie has also generated a word model to help this classification. I can edit this to give Gracie a better understanding of what I'm looking for. I can remove bias that's appeared through the building process to prevent Gracie from misclassifying, and I can reinforce features and words that are important to what I'm trying to classify. This human-machine teaming produces better results faster than other traditional machine learning methods. At this point, I have a fully functioning model, so I can go back to the editor to see if we're picking up the research paper. As you can see, we are now classifying this as a research paper, which is perfect. At this point, our model is looking good. We have successfully built a research paper model in 1 second using only 26 training texts and no negative texts. The next step in this process is to QA our model. To do this, we can navigate to the Validation tab within the skill. This area is where you can create a testing suite to ensure your model is accurate in the environment it will be operating in. Here I can add negative testing sets, in this case, things that are not research papers, into this new negative group called Research Paper Articles. I'm adding articles on how to write a research paper. While the language should be similar to research papers, they are not examples of them. These should have true negatives and should have a low proximity. In a positive bucket, I can add our true positives, which are the research papers themselves. After this process is done, I can click Start Run and get my score. We now have a star rating for the model. This is based on the F1 score, so we can see at a glance how well this model is performing. In this case, our model is performing very well, with an F1 score of 0.96 for this testing environment. I can also visualize my results. This will help me understand where I need to improve my model's performance based on the testing environment I've set up. Here we can see the range of proximities for each testing set's documents. If I click on one of the bars, I can see those documents appear on the right. If you look on the right, you can see the purple, or the document model's influence, is usually the smallest part of each proximity graph. This is telling me that my document model is underperforming, and that adding more training text will increase accuracy. On the other hand, my match list, the blue in this graph, is performing well. This makes perfect sense. We've only used 25 training texts, so Gracie doesn't have a complete understanding of what research papers are. However, we're already showing a great ability in disambiguating between texts talking about how to write research papers and texts that are research papers themselves. If your F1 score meets your needs, you're done. In this case, a 0.96 F1 is more than enough for us to use this in production. When compared against competition or DIY solutions, Gracie's time to value is in a class of its own, with other tools requiring drastically more training text, negative examples, and days or weeks more of additional building time to accomplish what we accomplish in minutes. For this demonstration, we built a document type classifier in less than a second, using less than 30 examples, QA'd our model, and tuned it without needing to know anything about machine learning. Our multi-class classifiers, or profiles, are extremely helpful for two scenarios. The first is when what you're trying to classify is extremely similar and hard to differentiate from other classes. These are things that even humans have a hard time distinguishing. Think of contracts. Unless you've dealt with contracts for a long time, the amount of boilerplate and legalese results in all contracts looking alike. Profiles solve this problem by absorbing the knowledge of each individual contract and using our big model, understand what each contract is relative to all other types of contracts. The second problem Profile solves is when you know there can only be one correct answer. Gracie's baseline models will provide a score telling you how similar the text you're looking at is to the models you've built. If I were to give Gracie an NDA, Gracie will tell me that it also looks like a handful of other contracts. While this is true, we want Gracie to give us one answer. This contract is an NDA, nothing else. For this example, we're going to work with source code using a skill set that contains skills, or models, for identifying different programming languages. By the end of this video, I'll be able to submit any source code and have Gracie tell me which programming language it is. If we process a training text from our Java skill in the text editor, we can see that it's coming up with a high proximity to a few other programming languages. The top language is Java, then generic source code, and then other languages. While Gracie is correct classifying this document based on the highest type, what we want is for Gracie to choose one programming language. A piece of source code can't both be JavaScript and Java. This is a perfect opportunity to use a profile to increase the accuracy of each programming language skill. To do this, we can navigate to the Profiles tab. Here, we can add a new profile, which I will call Source Code. Within this new source code profile, I can add my features. These will be the skills that share a lot of overlap, or where I know that only one can be chosen. In this case, they'll be the programming languages. Once I've added all of my features, I can build my new profile model by clicking Build Profile. Gracie is now learning what each individual programming language is based on what it looks like in context of all the other languages I've selected. This operation requires no additional training text for any of the features that I've specified. Once the profile is finished building, we can see the results. By clicking on the QA section at the top of the screen, I can see an accuracy graph for this profile, as well as the accuracy metrics for each feature. We've got some great F1 scores for a lot of our features. Keep in mind, none of these skills were edited in any way, and all of them only have 75 training texts. On the left-hand side, we have our accuracy graph. This tells us what the texts were classified as versus what the texts actually are. An accuracy graph for a high-performing profile will look like this one, with a strong straight line going from corner to corner. For example, this first box here is telling us that we have correctly classified 14 of 14 Haskell texts as Haskell, giving us a perfect accuracy score. There are two ways to increase the accuracy of profile models. The first is to provide additional training text for each of the features. The second is to increase the accuracy of each profile's underlying skills. If I want to increase C's accuracy in the profile, I can make the underlying skill of C more accurate. This helps not only our profile's C to become more accurate, but it will increase the accuracy of all the other programming languages, since they all lean on each other to do their own classification. If you're satisfied with your F1 scores, you can see your profile in action in the text editor. Paste in some text of one of the features that you specified and analyze the text to see your new model. If we look at the skill set's results, we find that it's correctly classified this as source code, but the particular language, Python, is very close to a lot of other languages. This is the reason why we built source code profile in the first place. If we look at our profile results, we can see that Python is the top result by a wide margin, meaning we've correctly classified this text with our new profile. Each of the underlying skills used only 75 training text, no negative training text, and took seconds to build. Improving just one of these skills will improve the accuracy of every other feature in the profile. This isn't just helpful for source code though. We've used this to determine differences in types of similar contracts, as well as differentiate hate tweets from offensive tweets. To recap this demo, we created a new model using our existing ones that helped pull apart the overlap in classification and drastically improved accuracy without needing to do any extra work. Using these three features, we can build almost any type of model for any vertical application. As an example, here's a dashboard that visualizes a data lake for an investigations team empowered entirely by our models. All of the models that you see in this dashboard are built the exact same way that we built the models in the previous demonstrations. In the top left hand, we have the total number of documents that were processed, sorted by the collection that they belong to. In the middle, we have three columns around entity risk, doc type risk, and content risk. Entity risk is used to identify things in the documents like credit card information, PIN numbers, social security numbers, traditional PII. Doc type risk is using the same technique that we built the research paper in, identifying documents by what type of a thing that they are. Here we're looking at all of the balance sheets that Gracie has classified and their text. We also show users what the most risky chunk of each document is, so they don't have to know where in the document to jump to. On the right-hand side, we can see the chunks and a large entity risk on the 12th chunk of one of our documents. If we select it, we can see that it's slides 40 through 46 of a presentation. If we look at the text of that document, we can see that it's filled with personal information. This dashboard can be used to show any type of risk. If the user used Gracie to build political speech models, this dashboard can be used to represent politician speeches and the subject matter within those speeches. If a user built source code models in Gracie, this dashboard then represents different types of source code that are found in the data lake, as well as entities like public and private API keys, passwords, and usernames. If you're interested in learning more about Topos Labs, you can visit our website at toposlabs.com, or you can check out our YouTube channel to see more demos like these.